Hey friends, so today is going to be a day of curve sketching. And so in that sense, I don't think anything is going to feel really weird to you because this will be kind of the third time we've looked at curve sketching. We looked at curve sketching in Unit 3 as we built all the way to the end. And then we took a day and looked at curve sketching just for trig functions. And now we're going to take a day and look at curve sketching just for exponential and logarithmic functions, okay? But the process that we do hasn't changed. The things we're looking for, the things we're asking for you to communicate to us in your analysis are exactly the same, okay? So we're going to be looking for domains, intercepts, symmetry, asymptotes, intervals of increase and decrease, maximum and minimum points, concavity, as well as possible points of inflection there. Possible points of inflection, and then the graph, okay? All right, so this is the one we're gonna go through together. We're gonna try and sketch the curve of y equals x times e to the x, okay? So the first conversation we wanna have is around the domain. When you're thinking about domain, you need to think about the fact of, like, we always start with saying, okay, well, let's say x can be anything I want, and then see if there's any restrictions. There's no restriction on the x here, and there's no restriction on the x here. If you think about any sort of exponential graph, regardless that the base is e, any sort of exponential graph there has all permissible values for x. So the domain for this guy is negative infinity to infinity, okay? Now we want to take a look at the intercepts. If I plug 0 in for x, I would end up with 0 times 1, because e to the 0 is 1. 0 times 1 is 0, which means I have the point 0, 0, which also tells me that's the y-intercept, right? Because the y value there was 0. So I have one intercept at 0, 0. As far as symmetry goes, we want to test whether the function is odd or even in order to talk about symmetry. So first thing we're going to do is take a look at f of negative x. That would be negative x e to the negative x, which is not y equals, like, it's not the same as y equals x e to the x. So now we're going to look at negative f of x. That would be negative negative x e to the x. Also not the same, okay? It's not the same as, so f of negative x is not the same as my original function, and negative f of x is not the same as f of negative x, okay? Because of that, it's neither odd nor even, which means there's no symmetry to discuss for this guy. Okay, so now we're taking a look at asymptotes. So there's no vertical asymptote. Just think about a general exponential graph, right? There wouldn't be a vertical asymptote. Let's take a look at the horizontal asymptote. In order to do the horizontal asymptote, we need to take a look at the limit as x approaches infinity and the limit as x approaches negative infinity. If I approach infinity here, so if x is getting really, really big and x is getting really, really big here, I end up with a really, really big number, okay? So the limit as x approaches infinity is actually infinity. It doesn't exist, okay? But on the other side, as x approaches negative infinity, what happens right here is I end up with 1 over e to the x. And we know that 1 over e to the x would approach 0. So this becomes x times 0, which is 0. Okay, so as I approach negative infinity, I end up with 0. So remember, I don't have to have it approaching the same thing on both sides. We've talked about that when we talked about asymptotes. So I do have a horizontal asymptote, and it would be at y equals 0. Okay. Okay, intervals of increasing and decreasing. I need to get the first derivative to have this discussion. X times e to the x, that's the product rule. So I'm looking at the derivative of x, which is 1 times e to the x, plus f, which is x, times the derivative of g, which would be e to the x. Okay, so I end up with 1 times e to the x plus x times e to the x. I want to factor the e to the x out. So I'd have e to the x times 1 plus x, okay? Critical numbers would be -1. So I'm going to test -1, test to the left and test to the right. I should end up with negative on the left and positive on the right. Okay, so that tells me I am decreasing from -infinity to -1, and I'm increasing from 1 to infinity. It also tells me that there's a local minimum at -1, comma, and then when I plug in -1, I would get out -1 times e to the -1. Well, that would be -1 over e. Okay, so I have a minimum point at -1, comma, -1 over e. Okay, now when you go to graph that, you're probably going to want to use a decimal approximation just to get a decent picture of where -1 over e would be. Okay, awesome. Okay, now we're going to head over to concavity. Okay, so with concavity, there's the first derivative. Again, I'm just going to hide myself for a quick second. I just listed the first derivative there. I'm going to look at that again as the product rule. So I've got e to the x times 1 plus x. So if I go derivative of f, that would be e to the x times g, which would be 1 plus x, plus f, e to the x, times the derivative of g, which would be 1. Okay. Now I'm looking at this and I'm saying, okay, I can again factor out an e to the x from both of these terms. If I factor out e to the x from both of these terms, I'm going to be left with it being multiplied by 1 plus x plus 1, which is 2 plus x. Okay, so the second derivative is e to the x times 2 plus x. Now, I'm going to set that equal to 0. We're not going to call that critical numbers, but I'm going to check -2. Okay, so when I check -2, check to the left, check to the right, I end up with negative and positive. Okay, so that tells me I'm going to concave down from -infinity to -2, and I'm going to concave up from -2 to infinity. Okay, it also tells me I have a point of inflection at -2, and if I plug -2 back into the original equation, I'd have -2 times e to the -2, which would be -2 over e squared. So I have a point of inflection at -2, comma, -2 over e squared. Okay, so then the last thing to do here is to graph that. And again, with that -2 over e squared, you probably want to get a decimal approximation. Okay, so go ahead and try and graph it. Remember, you want to label all your points. You want as smooth a curve as you can. So this is roughly what you should have gotten. Okay, so we see that horizontal asymptote here. We then see it bending down to my minimum. We see the point of inflection, and we see the x-intercept, and then I shoot up from there. Okay. So I only have one example to go over with you. As I said, this should feel really familiar to you. It's just that you're doing it through the lens of looking at exponential and logarithmic graphs instead. Okay, so I've got your homework here posted. If you have any questions, make sure you connect with me and have fun. It's going to be awesome. Take care, guys.